Welcome back, gamers. Thanks for being curious about the eools engine. I'm just going to call it eools for now. Pronunciation is not a problem. Whatever works. Now, I'm just going to walk you through my thought process when making this and what it actually does in detail. So this is purely just going to be about the engine, not about how the game is actually put together. You get some insight, but that's about it. So let's bring in this cool diagram we got here. Anyways, so in the background, our right side of the screen are two clients. Our left side is the server. Now, clients are just there for demonstration and reference, but whatever. So the point of a networked game is to sync instances between the data between instances across our clients. So in a server setup or server client program, like how this is done, each client updates, or the server keeps a record of like all objects, what the scene is currently as in like Unity terms, the game world, whatever. And clients are sort of self-manage what objects they're responsible for. They could create it, and then they send, hey, this is a new object to the server, and the server updates its own world. Now, when the client requests an object that says, hey, I received this packet for this object with this ID, but I don't have it on record. Give me the whole thing, and it'll request it to the server. And because it's all cached and stored on the server, it doesn't have to go ping back to the original client with the data. It says, "Oh, I already have a copy. This is it. That's that. All that good stuff." But because it's sort of that back and forth communication between the two, this is just a complete trust system. If you could snip in a packet or stuff it in between there, you could fake it and it'll just trust you and say, yeah, that looks good. I'm recording it as like a real event or whatever, and I'll propagate through all the other clients. But anyways, now these instances are kept track of by a actual integer value, a instance ID. Now the instance ID for each game object is the same across clients, and how that's done is just like implementation details. You could figure it out probably. Hopefully, it's not as intimidating as it is if that's what you're thinking. But anyways, it's a say client down here. It's every frame or so it'll send its information, its rotation, its position, movement, all that stuff to the server. And at the same time, for the client up here, every frame or two, it requests from the server, hey, this thing seems to have moved. Where is it actually now? When? What changed? All that good stuff. So the server is just our broker between the two. But the way this works is to actually sync a message or packet between the two, or the way I designed it is that it's sort of a class-based ID system. So in this drawing here, we have class A, and if we poke it down here, we also get a few other classes, class B and C, which are derived of class A. So you could think of class A as your, I guess, base game object, with B deriving off of it, and C as like the child of all of them. Now, if you're an object-oriented and learning about UMLs, you may notice the arrows are going the wrong way, but like, this is a technological limitation, and you know what I mean by this. But anyways, what eools does is throw in a factory system with these numbers, and it can uniquely ID each of these classes with a integer value too. So it's just like instance IDing, but for classes. Now, I had to add in this factory system in the first place and not just use some like C++ variable like type ID that could already uniquely identify classes, because through this factory system, these IDs are maintained regardless of what you built, what system you build it on, when you build it, and essentially however you set this up, which is unlike anything else in C++ as far as I know. So that's what this factory system does, a consistent compile time unique ID for each class. Now, pardon me, and if you notice on the other side, each class has their own two functions, a pack and unpack message. Now, message in this case is a network message, and it's split up this way because class A is your game object. It's responsible for like your transform, your position, your rotation, that stuff. Class B could be like your ship over here, or base ship, and it says a movement, I don't know, like our drive output, our generator, it's responsible for that data. And class C is like you're derived off a ship that got some other stuff it handles. But the data is really the new data each class introduces is only handled by that exact class, which makes for a lot more intuitive code and a lot less clutter. So because we have a unique ID for each class and a unique instance ID, that's all we really need to match a message packet from one client to the other. So in this case, I guess like client A sends a ship with a instance ID of 1 million around here. And that comes in down the line. It's also got a ship class ID attached to it. So I'll just say in this case too. So we take the instance ID and the class ID, and we can map it using the instance ID. We are able to map it to a specific instance that is on the other client's side. Now, if that specific instance doesn't exist, that's like another implementation detail. You can send it back and forth and like sync them up and create an instance. But so let's just assume the simple case, it already exists, everything's happy, it's synced already, we're just updating it. So takes the instance ID and finds specific instance on the other client, and then it takes the class ID and then finds the specific version of the function it should be calling. So even if it's the instances of a class C, if we have a class ID of 2 in this case, we could actually call the class B implementation of that function and pass it all to message data. And that's pretty much it. It's just a nice way of syncing. So yeah, thanks for listening to my TED Talk and such.